Class 8 Maths Chapter 1 Rational Numbers. Let's understand what are rational number and the properties of rational number. Rational number are those number that can be expressed in the form of p by q, in which both p and q are integers and q is not equals to 0. For example, 2 by 3. 2 and 3 are integers, so 2 by 3 is a rational number. 4 by 5 minus 2 by 3. 4 is also a rational number, as 4 can be written as 4 by 1. 0 is also a rational number, as we can write 0 as 0 by 1, 0 by 2, 0 by 3, etc. All these are rational number. Now the properties of rational numbers are closure property, commutative property, associative property, distributive property, identity property and inverse property. Now let's understand these properties. Closure property. For two rational numbers x and y, the result of addition, subtraction and multiplication operations give a rational number. For example, if we take x as 7 by 6 and y as 2 by 5, so x plus y, which is 7 by x plus 2 by 5, is equals to 47 by 30, which is a rational number. So rational numbers are closed under addition. If we add two rational numbers, we get a rational number. Now, if we take x as 5 by 6 and y as 1 by 3 and subtract them, so 5 by 6 is a rational number, 1 by 3 is a rational number. So 5 by 6 minus 1 by 3 is equals to 1 by 2, which is also a rational number, which means subtraction, closure property under subtraction holds. If we subtract two rational numbers, we get a rational number. Now let's check for multiplication. Take x as 2 by 5 and y as 3 by 7. So if we multiply 2 by 5 by 3 by 7, we get 6 by 35. So if we multiply two rational numbers, we get a rational number. So closure property under multiplication also holds. Now let's talk about division. Is closure property under division holds or not? If we take x is equals to 5 and y is equals to 0, so x divided by y is equals to 5 divided by 0, which is not defined. According to the definition of rational number, denominator should not be equals to 0. So closure property under division does not hold, because division by 0 is not defined. Now commutative property. For rational numbers, addition and multiplication are commutative. Commutative law of addition states that a plus b is equals to b plus a. If we take a as 1 by 3, which is a rational number, and b as 2 by 3, which is also a rational number, so 1 by 3 plus 2 by 3 is equals to 3 by 3. And b by a, 2 by 3 plus 1 by 3 also gives 3 by 3. So commutative property for addition holds. Similarly, for multiplication, A into B is equals to B into A. For example, if A is 2 by 5 and B is 3 by 7 is equals to 3 by 7 into 2 by 5. So 2 by 5 into 3 by 7 is 6 by 35. 3 by 7 into 2 by 5 is also 6 by 35. So commutative property for addition and multiplication holds. Now let's talk about subtraction and division. If we take A as 2 by 3 and B as 1 by 3. So 2 by 3 minus 1 by 3 is equals to 1 by 3. And 1 by 3 minus 2 by 3 is equals to minus 1 by 3. So A minus B is not equals to B minus A. So commutative property for subtraction does not hold. Now for division, if we take A as 4 by 9 and B as 1 by 2, so 4 by 9 divided by 1 by 2 is equals to 8 by 9. But 1 by 2 divided by 4 by 9 is equals to 9 by 8. And 8 by 9 is not equals to 9 by 8. So A divided by B is not equals to B divided by A. So commutative property for division also does not hold. Now associative property. As commutative property for addition and multiplication holds, similarly associative property for addition and multiplication hold, but associative property for subtraction and division does not hold. Associative property states that if x, y and z are rational numbers, then for addition x plus in brackets y plus z is equals to x plus y plus z. For example, if we take x as 1 by 2 plus y as 1 by 4 plus z as 2 by 3. So left hand side gives the answer 17 by 12, and if we simplify right hand side we also get 17 by 12. So associative property for addition also holds. Now for multiplication, 1 by 2 multiplied by 1 by 4 into 2 by 3 is equals to in brackets 1 by 2 into 1 by 4 into 2 by 3, which means A into B into C in brackets is equals to A into B in brackets multiply by C. So associative property for multiplication also holds, but as commutative property for division and subtraction does not hold, similarly associative property for division and subtraction also does not hold. Now distributive property. The distributive property states if A, B and C are three rational numbers, then A multiplied by in bracket B plus C is equals to A into B plus A into C. For example, if we take A as 1 by 2, B is also 1 by 2 and C is equals to 1 by 4. So 1 by 2 into 1 by 2 plus 1 by 4 is equals to, first multiply 1 by 2 by 1 by 2, put the sign of plus as it is, then multiply 1 by 2 by 1 by 4. So 1 by 2 into 1 by 2 is 1 by 4 plus 1 by 2 into 1 by 4 is 1 by 8. On adding we get 3 by 8. Identity property. 0 is an additive identity of rational numbers. If a is any rational number and we add 0 to a, we get a. Or if we add a to 0, we get a. So, if we add 0 to any rational number, we get the same rational numbers. So 0 is the additive identity for rational numbers. For example, if we add 0 to 2 by 3, we get 2 by 3. If we add 0 to minus 4 by 5, we get minus 4 by 5. So 0 is the additive identity for rational numbers. Now, multiplicative identity. If a is any rational number and we multiply it by 1, we get a. So 1 is the multiplicative identity for any rational number. For example, if we multiply 2 by 3 by 1, we get 2 by 3. If we multiply minus 3 by 4 by 1, we get minus 3 by 4. So 1 is the multiplicative identity for rational numbers. Now, additive inverse and multiplicative inverse. For a rational number x by y, the additive inverse is minus x by y. If 2 by 3 is the rational number, so additive inverse of 2 by 3 is additive inverse of 2 by 3 is negative of 2 by 3, which is equals to minus 2 by 3. Additive inverse of minus 6 by 5 is equals to negative of minus 6 by 5, and minus into minus is plus, so additive inverse of 6 by 5 is 6 by 5. So we can say that additive inverse of a given rational number is the negative of that given number. Now multiplicative inverse. Multiplicative inverse of a rational number x by y, multiplicative inverse of x by y is equals to y by x, or we can say that the reciprocal of x by y. So the multiplicative inverse of a given rational number is the reciprocal of that number. For example, multiplicative inverse of 3 by 4 is equals to reciprocal of 3 by 4, which is 4 by 3. Same multiplicative inverse of 1 by 3 is reciprocal of 1 by 3, which is equals to 3.